Geometry, Unit 1, Section 5, the centroid. Now, the first thing we're trying to do here is construct two medians for the given triangle to locate the centroid. All right, couple of notes. First of all, this for a median, let's talk about that first. A median is a line that connects, how do I want to word this? An angle to a midpoint. A line that connects, oh, that's pretty sloppy. An angle and a midpoint. That's what a median is. So a median, you need an angle. Like here's angle C, for example. I want to connect it to a midpoint. Now I can't connect an angle C to the middle here because that's line AC, and same thing here. So you're always connecting it to the side opposite the triangle. So what side is opposite angle C? Side AB. So I need to find the midpoint of AB. Let's say it's somewhere around here. Again, don't draw this right now. Let's just do a rough sketch. And if I were to connect that, that would be a median. It goes from an angle to the middle of the opposite side, to the midpoint of the opposite side. So how do we do this with a compass? Well, we know where the angle is. We know where angle C is. What we don't know is where the midpoint of this side is. And all three of these sides have midpoints, and so you can connect them to the opposite angle. So there's actually three medians we could draw here. We could draw the one from C to the midpoint over there. We could draw one from B to the midpoint over there. And we could draw one from A to the midpoint over there. So there's three medians you could draw. All three of those medians cross at the same spot. They all intersect at the same spot. That's called the centroid. It's where the medians cross, where all medians intersect. So make sure you write those two things down, because medians and centroids is probably new words for you. All right, so first we got to find a midpoint. So let's find the midpoint of, I don't know, let's do AB, the one we were kind of working with first here. So how do we find the midpoint of AB? We've talked about midpoints a little bit. Well, we actually find the midpoint by doing a perpendicular bisector construction. So really what I'm trying to do, because the perpendicular bisector, now we don't really care about the perpendicular part of it, but we care about the bisect, because if we bisect line AB, that means we're going to find the middle of it, because bisectors cross at the middle, they cross in midpoints. So if you remember the perpendicular bisector construction, I just need to extend a little more than halfway and draw about half an arc. Flip it around, do the same thing there, a little more than halfway. Where the arcs cross, place, a little point there, a little point here. Draw a line connecting those. That's the perpendicular bisector, but really what we're using it for is where the perpendicular bisector, again, I don't care that it's perpendicular here, I care that it's bisecting AB. So that means that this is the midpoint. It's the midpoint of AB. And that means it's basically the point in the middle. And so this line, this perpendicular bisector I drew, that's not the median. The median is now the line that I'm going to draw the line in color. I'm going to draw it in. Let's do green. So going from the midpoint to the angle across from it, that is a median. It goes from an angle to the middle of the opposite side. That's what a median is. All right, so that's one median. If we do another one, which we're going to, then where they cross, that's the centroid. So we got to find another median. So let's do the median of BC down here. So go to BC, extend it a little bit beyond halfway. I'm going to go back to blue. I'll do my arcs and blues today. And might have to look below the page a little bit, but it's okay. Hopefully you have plenty of space to work with. Now this will get a little messy, this construction, because you got a lot of arcs going on and stuff like that. So right there. Now notice that I went Middle's probably somewhere around here. I went pretty far past that for my arcs. If I made my length like just past halfway, then it would probably the arcs would be smaller and it would cross a little bit easier. So you could always you do have a built-in ruler on your straight edge. We never use it to measure things, but you could use it to kind of approximate the middle and then just go a little bit further. Then maybe your arcs won't be so big. But anyways, it's okay. So I need to draw a line connecting these to complete the perpendicular bisector. But what I really want is the midpoint part, the bisector part. So that is the midpoint of BC. And now I can move my compass out of the way, done with that, and go draw another median that from this point to the opposite angle, which would be A. Where they cross, where the medians cross, this is the centroid. Very sloppy centroid. Now, I could do the third one, but I can guarantee you it would cross there because they all cross at the same spot. So I could actually do a very easy construction, just connect these, and that'll help me find the midpoint over here, AC, because the medians always all cross at the same spot in a triangle anyways. All right, the centroid is important. Well, we've talked about some other things where things cross, like where the perpendicular bisectors cross, the angle bisectors cross, and stuff like that. Maybe we've thrown the word concurrency out there. Well, the centroid is actually a little more important than all of them because there's an important property attached to it. So I have here a picture of a triangle with the three medians drawn. So this AD here, that's a median. This EB is a median, and FC is a median, right? Because it goes from the angle to the middle of the opposite side. And then I tell you that point P here is the centroid. So I could tell that these are all medians because they're crossing at something called the centroid. That makes them medians, and that makes these midpoints, and so on. Let me just highlight one of these lines for a minute. Let's just look at one of them. Let me get a highlighter tool out. If you have a highlighter, you can use it. If not, don't worry about it. I just want to look at one median here. I'm actually going to make that thinner. It's a little too thick. Nope, I thought it would straighten out for me. Try one more time, and then I'll give up. All right, not bad. All right, so this median here, AD. What's important about the centroid is it actually splits your segment into specific lengths as far as ratio goes. Now, AD, does it look like it's being cut in half by point P? No, it's not. It's not a midpoint of the median, but it does have a ratio. And the key is that it kind of creates two segments. It creates a long segment connected to the angle and a short segment connected to the side. These segments, long segment to short segment, has a ratio of 2 to 1. And basically what that means is the long part is double the length of the short part. And not only that, the whole median, the ratio of the whole thing to the short part, so the ratio of the whole AD to the small piece is 3 to 1. And the ratio of the whole thing to the long segment is 3 to 2. So what that means is if you know that, like in this part here, part A, AD is 15. So if this whole length is 15, my small piece is a third of that. And a third of 15 is 5. And my long piece is double that, 10. So 10 to 5 is a 3 to 1, the whole to the short. 15 to 5, sorry. 15 to 10 is 3 to 2. And the two segments together, 10 to 5, that's a 2 to 1 ratio. So if you know the whole thing, divide it by 3 to get the smaller piece, and then double it to get the longer piece. I want to draw a better 5 there. I didn't like my 5. It's better. How about the other ones? So these are really quick problems. EP is 3. So EP, this little piece is 3. That means the longer part is double the smaller part. The longer is double the smaller. Why did I say 10? That doesn't make sense. 3 to 6. I'm still thinking 5 to 10. The short part is 3, the long part is 6. It's double. And so the whole thing would be 9. Again, you can see, the whole thing's just a sum. Anything's a sum of its parts, right? And you see that the whole thing divided by 3, that's a small part. So they want, let me put these answers over here. AP was 10 and PD was 5. It's an ugly 10. PB, the longer part, double the short 6, and the whole thing then would be 9. And one more on here. CP, the long part is 14. That means the short part's half of that, 7. So FP7, and the whole thing would then be them combined 21. So it's basically just remember that the long is double the short, and the short is a third of the whole thing. Then it's some really basic math there. I mean, maybe we'll throw some software X type of stuff in with this when we practice it, but that's a simple concept. But it comes from the fact that all the medians, which go from angle to midpoints, all cross at the same point called the centroid. See ya.